let's get started. I have a question unrelated to this class. How many students have received a notification that you haven't met the prerequisites for the courses you signed up for in the spring semester? Okay, just 3. Okay, this is something new they're doing, which they didn't. If I was not informed until this afternoon, and it's not clear how they plan on checking for graduate students, because if you didn't do undergraduate work here, how is the registrar's office going to know what class you took is comparable to one of our classes? Right? And since they didn't tell us, that was going to happen, they clearly didn't tell us how they plan on resolving that issue. They do plan on kicking people out of classes at the end of December if that's not cleared up, right? I don't know. I mean, oh, at least one person got a target email saying, this is your list of classes that you don't have the prerequisites for. Well, so there's no target. It's just when you registered. Yeah, no, this is school-wide. I mean, like I said, I just learned this afternoon, and so the email you guys got, I haven't seen. I mean, I have no idea. I think I'll plan on being offline December 31st and January 1st. Well, it used to be when registration was in the summer. Every summer you'd get these panic emails because students were admitted conditionally, and they would take the conditions and forget that there's a form to fill, right? And so then they didn't notice there was a hold on the registration. And it's like the morning they were going to register, they logged on like, I can't register. And they're in a panic because all classes would fill up. And like this panic email, can I see you in 5 minutes? It's like, well, I don't think so. And besides, even if you did, you have to get this form signed, and it's going to take a day to get it processed. But those things are painful because then the students can't register, and then on the wait list. So, any questions? So we have 2.5 weeks left of classes, and from the Gang of 4 textbook, we've got 2 patterns left to cover, which we'll do today, and then we'll talk about other patterns which don't appear in that text, various types. So the first pattern talk about is a mediator pattern. And there we go. And I must admit that if I was to ignore a couple patterns in the Gang of Four book, this would be one of them. And the reason is when we talk about like controllers, the word controller sort of infers that, oh, we are actually controlling things. And so the controller starts doing lots of things for other classes. And so the other classes become smaller and smaller, mainly structs. And then you got this one big class that's doing all the work. And we have a similar problem here is with a mediator. I mean, there it is, controls, right? And once you start saying controls, people think, well, it has to do all the work, right? And so it becomes this thing that's really doing a lot of work, and then all the things that you're interacting with tend to be just data structures. Yeah, the mediator becomes the program, right? It does everything, and then a main, yes, and it has to know how all A, B, C, and D work, right? And that's the problem is once you do that, right, now the logic becomes more complicated because you're doing all the work for A, B, C, and D, right?
How that like actually works.
Well, but the key part is, it just says, it controls and coordinates the interactions, right?
But does it have like factors in it that do like function objects, like similar to what the man pattern did? It just generates them on the fly, calling them the object.
Let's just look at, no, um, they're more of an example. You have a dialog box, right? And you have various widgets. Um, and, sometimes what happens is until you selected a list, the button may not work, right? Because it doesn't make any sense to say I'm done because you haven't done anything yet. And so then what we need is when you select something on the list or you put an entry in, then the the button can be enabled, right? And so do you really want your list box to know that it has to um, enable a button when it's something selected? I mean, not really, right? The list to just say, okay, here's what's been selected. So then, the mediator is the one that says, oh, okay, right, I got notified that they selected something on the list, so now I can update the button to be enabled.
Would it better, maybe
Yeah.
instead of just having a mediator, having a mediator? Really complicated to implement into the next system.
Oh yeah, but then
Mediator.
yeah, in this context, I mean, you've got a dialog box or even a window. Um, you're not going to need that complexity, right? Just
Kind of.
well, but again, we're not talking about whether there's things that I can concurrently assist. Have you, you know, we entered something in the entry field, and so, okay, maybe the list box and the button have to do something in response, right? But we don't want the entry field to have to actually do that, because this entry field, you just want to know what's there. Is something there or not there, right? Or has it changed? So that's, basically, why the formatting. Basically, all it says is this, right? Is that there's a mediator, right? And each of the participants just knows what the mediator doesn't have to know about the concrete classes, and it just says, okay, this happened to me, right? And then the mediator can then do the appropriate thing on, right, whatever the various related other participants. Right, it's also where you can start, reactive programming starts to come in, because now we can basically, if the mediator respond to events that are generated by the participants, then basically when we wire them together, we just say, okay, this event gets triggered and transformed into calling this method over here. And so this is, right, that a brief discussion of the mediator pattern. And that's why be careful. It's not meant to be a God class, right? It's just, right. So the Dialog example, right? I mean, you set it up, or when you create it, okay, we know how things are supposed to be related, right? Well, so I mean, these classes work together, right? And as they communicate them and do various things, and different times, and how do we do that without? And this examples are hard to come by in the mediator pattern.
Oh, like if you need a functionality that's distributed over several classes, and you need them to occur in like a specific case.
Well, not necessarily the order. It's just, well, again, we're not talking about concurrency here. It's just that, sometimes you want to operate this way. In other cases, maybe you want to operate slightly differently, right? So how do you do that? Well, we can create a subclass each one to operate.
The subclasses are probably too specialized for
Yeah.
the content.
And so just have the mediator, each mediator for each different way you want to do it, right? So here's an example that I came across. Again, dialog box. It's basically a font selector, and yeah, we can pick the sizes. But when you pick on the font, right, there are different options which are available depending on font it is. Certain sizes are not always available. There may be colors. And then when you pick the font, it shows you the comparison between the standard font and what you selected, and then you can start selecting, right, various font options. And right then we can, create name fonts, and so we can add it. And when we do that, it has to, right, add it to the list. And if we select one without the default, this one should be enabled, but it's not enabled now. And so there's all this interaction between the small pieces, and all these pieces are the standard buttons, right, with text and labels, and when you click on them, they trigger an event. And these are just, standard edit panes, and these are just labels, but the labels are determined by what things have been selected. And so how you put that together? Well, you want one thing, how the things coordinate, and so the other things don't have. You really don't want this label to have to know about this list, right? But again, we can easily now start imagining ReactiveX, right? Right. Whenever you select this, it's going to generate an event, and then we can, right, make this a listener on that event and pass it the name, and then it displays the name, right? And then this drop-down menu has to know how many different font sizes there are, so we may have a different listener which will it'll pick out all the font changed, and now we have to go and find the sizes that are appropriate for that font. But and again, the OK button shouldn't be enabled until, right, both the username and password have been set, right? And then I guess just trying to right, put the logic in, well, we don't want our buttons to know about the text fields, right? So this doesn't make sense to have a subclass button so it knows about password file and password. It's going to be easier to, have a dialog class which knows all the things related and operate appropriately. Right, and so yeah, we take, instead of creating these very specialized contorted subclasses of button, and right, we can just create a login dialog class and it handles that logic. Like I said, we can start imagining, using reactive programming to set up these dependencies, right? So when this button is clicked on, we have the stream of events that occur and updates various other parts of the participants appropriately.
Did you say that if all the patterns this one?
Well, I would not talk about it, this one and the facade. No, no, no. No, it's just that as soon as you start saying, "Oh, this is going to control things," right? Then people start thinking, "Well, it's going to do all this work." Just handle the communication between, right?
So is the mediator just supposed to be a pass-through between several objects, or do the objects send a request to the mediator evaluate the request, and call some people?
Right.
Cool.
No, I mean, it does both. It can do both. It depends on the situation, right? Dialog button, right? This dialog, this one, right? It's very simple, right? What should the OK do button do? Well, if it's always enabled and you click on it now, it should pop up another little window saying you have to enter some data, right? And then if the username and password are entered, then it does, it calls something to actually validate those to make sure they're correct, right? The more complicated example, right? You select a font, and we have to update the size, and the color might have to be updated, and then the sample text has to be updated, and the label has to be updated. When we select another name font, this has to be enabled, right? When I click on this add new name font, then we need a new name for it, right? And then it has to be added to the list. But all these things, there's standard buttons, standard labels, standard drop-down menus, right? How do we make them all work together to Dialog? And of course, in this example, right, it's somewhat easy to think about this situation, but the pattern isn't meant just for Dialog boxes, right, or windowing systems. Yeah, and when does that happen, right? And I suspect very few students that are come across a situation where this would apply. So I forgot there's one more pattern to cover we haven't done yet. So flyweight, this one's an easy one to explain, but harder to figure out when you need it. So it says you want to support a large number of fine-grained objects efficiently. So the example is you have a large text document, right? And you've got different fonts. And so the text document, I mean, we think of it as just text, right? But each character has a font associated with it, and the size of the font, and the font, and the width, and the height, and ascenders and ascenders, all this type of stuff, right? And you've got 50,000 characters, right? Then do you really want, how many copies of A are in the document? Do we need a different A object for each one of them? Can't we use the same A object? But some of those have different fonts, right? So how do we deal with that? So in Java, which a lot of people don't realize, is that when possible, Java, they intern strings. What that means is, like here, I have two strings, cat, rat, and cat, and then when I ask is A1 equals A2 plus, right, rat, the answer is false, right? But now when I take A2 and I add rat to it and I call intern on it, and now I ask is A1 identical to A3, the answer is yes. And by identical, what we mean in Java is what? They're in the same memory location. So basically A1 and A3 are the same object, right? They point to the same object. Not that they have the same character sequence, because A2 plus rat has the same character sequence as A1, right? And A4, I just say cat plus rat. And now I get the same string as A1 and the same string as A3. A single representation. Right. So what happens is when a string is interned, right, Java basically has a list of all the strings. When you say, oh, I'll intern this string, if it looks to see if it already exists, if it does, it always returns that copy, right? It's useful because now you get fast matching, right? And whenever you declare a constant as a string, it's automatically interned. It does confuse beginners because sometimes when I say A4 is equal to A1, it's true, right? But when I do the same thing, A2 plus is different, right? So why do I get a different answer? And the answer is string literals are always interned. Right? So that's an example where we get many copies, supposedly many copies of things, but they're stored efficiently. So to talk about the flyweight pattern, we have to talk about intrinsic and extrinsic state. Intrinsic is part of the thing, right? What's that?
The data sometimes it's data.
Yeah, it's like when characters, there's a character A, right? The ASCII code for it is the same, right? All A's have the same character code. Whereas all A's in your document may not have the same font information, right? Different fonts. And so extrinsic state is, things depend upon its context. What font is it? Well, it depends on where it's in the document, right? If it's in the title, if you have a different font than is it in the text, right? And so now for the flyweight pattern, what we want to do is we want to create a canonical version of each one, right? And so we can just use that instead of having multiple objects. The difficulty that the string example in Java doesn't have to deal with is the string has no extrinsic state. Right? It's just a string. It's just a sequence of characters. We're done. So if you want to do this, right, we have to worry about, the intrinsic state is easy. That's just part of the nature of the object, right? It's an A or it's a B. The font information, that's different. So what we want to do is we want to have a canonical representation but we have to pull the extrinsic state out and put it somewhere else. And then the question is, how can that be efficient, right? And so basically, yeah, we want to create a canonical representation for an object so we can have the same one instead of multiple objects. But we have to remove that extrinsic state and store it somewhere else. How do we do that to be and save space, basically, right? So the idea of a run array, right? So we have this, this character sequence, right? We can store it as two arrays, right? And the top array is just the first run, right? How many times does it appear? It appears 5. How many times does B appear? It appears once, right? How many times does A appear? Well, it appears 20 times, right? So how much space does it take to store these two arrays? No, we've got each array has got 3 slots, right? So we're talking 6 words, right? In theory. How many characters does a top string take? Well, there's 26 characters, right? So if we have a lot long runs, right, the lower representation is going to be more efficient storage than the top one. What's that? It depends. It depends upon your context, right? We're so used to devices which have so much space, right? I mean, how much memory does your phone have? 3 gigs? No, that's not the memory. That's your solid state storage, right? But the memory is probably only 3 gigs. I mean, 3 gigs in your pocket for memory, device in your memory. I mean, when I first started teaching, I had a class of 100 students. They had to work on a PDP-11, right? You didn't have a gig of memory. You had like 16 megabytes of memory. Everyone was sharing, right? When you start doing those type of constraints, you start worrying more about utilizing space well. Perhaps a better example is when the Macintosh first came out, you didn't have megabytes of memory. You had 256K, right? And you had one floppy drive, no hard drive. And the operating system had to fit on that floppy drive and your data. So they didn't use the ASCII character set because it took too much space. They actually did Huffman coding of strings to reduce the number of space it took because you were so limited. So they would do things like this just because you had so little space, right? When you got 3 gigabytes of memory and 16 gigabytes of storage, it's like, okay, why should we go that work to reduce the amount of space? Because right. So now what we're going to do is, say we've got a right. We have some text that has various font information, and we want to use a flyweight to represent each character, right? So for each A, we want to just have one A object. But the problem is different A in different positions may have different font information. So what we can do is, well, we can, you don't change fonts that often, right? I mean, you don't write 2 characters, change a font. I mean, usually it goes on for paragraphs. And so we can now take all that font information and store it as a run array, and then that extracts the extrinsic state from those characters, and now we can just represent all A's by a single A object and all B's by a single B object. And then when we come across it, we have to keep track of where we are so that we can then apply the right font information to it. Right, so the flyweight is basically, like I said, if you've got a lot of these objects, right, you're writing a book, right, and the book is 100 pages long, and your software stores each character as an object. There's a lot of overhead for each object, so why not have, one A object and one B object, and then.
So the flyweight is
The flyweight is just, I want to have a canonical representation for each of the objects instead of repeating over and over again. A representation of it. Well, we have to ask ourselves what object are we replacing, right? And in this case, what we're replacing is the objects are characters which have the font information associated with it, right? And so we have to pull out the extrinsic state to store it somewhere else. And that font information is the extrinsic state. Intrinsic state is just whether it's an A or a B or a C. And so then we need, basically 26 characters plus a few numbers and.
Is it kind of like let's check out the stats. Certain very, very specific. They're just counting.
Well, first you have to keep in mind the context of the flyweight pattern. You have a very large number of objects, right? And a number of them get repeated, right? So we want to reduce the amount of space it takes, the overhead, right? So can we, instead of repeating the object over and over again, can we have a canonical version of it? But the problem with that is different A objects have different states, right? It's Helvetica font, it's a bold Helvetica font, right? It's italic. So we just can't do what Java does with strings and say, well, okay, here is a pointer to a single A, because we lose information. So we need to pull out all information that's different between the A's, store that somewhere else. And so now we can have one A object and just have pointers to that one A object whenever we want an A. Right, the goal is to reduce overhead of storage. Well, so what we do is we create a single canonical version of A, right? Every time we cross an A in the string, there'll be a pointer to that particular A. But the problem is this A and that A have different information, right? And so we need to take those differences out so we can use that single A object. And so then what we would get is we would get the same string, but these would be pointers to the single A object, right? And then when you want to display the string, you can have to then calculate, oh wait, the first 22 characters I use normal. And the next 8 are going to be bold.
The actual data itself, which is the ASCII A with presentation on the screen.
In this example, yes. And the way they explain it is there's some information which is common among all of them, right? The ASCII code, or to be more precise, the Unicode, point for that character. But there's other information about it which can vary. In this case, the font and the size, right? And the yeah, 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 yeah. Basically, we have to pull out all the yes, yes. And so the question you have to be careful is you have to when you pull out all the extrinsic state, you have to store that, and you have to ask how much space does that take, right? And if it takes too much space, you made things more complicated, but yeah, but it gets complicated, right? Because then you're doing all this extra work to pull the information to put it back in at the time you need it. And the goal is to save space. You're not saving much space, then what's the point? So the reason I keep this one towards the end is because I don't expect anyone has ever come across a situation that would need this in an era where you have gigabytes of memory on your phones. Yeah, yeah, yeah. Right, where you are resource restricted. And those situations still occur, right? On embedded devices, although in embedded devices, they probably don't use object at all if you can avoid it. Because like in Java, there's like a 16-byte overhead just for an object, right? That's a lot, right? And if you're dealing with multi-terabytes of data, then you also might be resource constrained. Hmm. Well, if we're looking at the Flyweight pattern, the first question is, do you have a lot of small-grained objects? And by a lot, they mean really a lot. And if the answer is no, then forget it. I mean, you're not. Right? Yeah. I mean, that's what I say. I mean, Is, this is a situation I don't think any students have come across, right? A situation where you have a lot of small grained objects.
You just have some piece of data. Out of the instantiation share, that's kind of the same.
Well, we are creating a canonical representation, right? So one instance, but again, the motivation is different. You don't have, when you've got a class, you only want one. If you think of the class as an object itself, you only want one of them, right? Because you don't want a copy of the same class because they're identical, right? It's a little different. So why have?
Sure, but if you're thinking about like trying to separate out the inessential features of the class,
Right.
and just boil it down to its like.
But keep in mind, the flyweight pattern, we don't throw away information. We just store it differently to reduce the amount of space it takes. Now, I did remember there's actually one more pattern in the book we haven't talked about. We can do that next time, but it's also one that I don't like to talk about. Because it's, again, a situation that I don't think many people have ever come across. And, okay. So some other patterns, value object, which is actually becoming quite common these days. And then a different type of pattern, which most of you have heard of before. Some reference where this material comes from, and value object, right? So in language like Java, there are base types, right? Those are values, 1, 5, and 6, right? And they function differently than objects do, right? When, 5 is 5, right? And all 5 are the same.
Yes.
In Java, they are, right? Yes. I believe in Python too. And you can't change 5, right? I mean, you have a variable and you assign 5 to it, then you're going to assign 6 to it, but that's not changing 5, right? But I can have an object and I can change it, right? And change its state. And once we do that, then we have to worry about what does it mean for the two objects to be the same, right? Because we have two separate objects with the same data in their fields, but they're different objects, and there are times we want to consider them to be the same object, right? Whereas with values, it's clear what we mean by equal, right? It has to be 5, right? But we have lots of different types of values we use, right, in the real world. I mean, social security numbers are a value, right? Credit card numbers, they don't change. I mean, you can't change your credit card number, right? You get a new credit card with a new number, but that's different than, that's like having a variable X and you assign it 5 and then you assign it 6, right? You haven't changed the number, you just changed the variable which holds the number, which is different than an object, right? So there are lots of things in the real world that are really values and they're not objects, right? They behave like values do, right? And we can use, for a credit card number, we can just use a number, right? But the problem with that is you may want to perform certain operations on these values, right, that are common. And so where do those operations go, right? A classic example is money, right? The problem with money is, well, in the US, I mean, you really can't go, I mean, pennies is the smallest unit, right? But other currencies, you can go 3 different places out, right, instead of just 2. And what do you do when you have pesos and dollars, right? How do you keep track of which one's a peso and which one's a dollar? And how do you add them together, right? If you're representing money with just numbers, you can't do, I mean, it gets harder, but you have to keep track of, how do you keep track of the peso, right? And what happened when you had 5 pesos and $5? What do you get? 10 pesos? I hope not, right? $10? I don't think the bank is going to go for that, right? I mean, so if you do any significant work with money using integers and floats, this won't work, right? But we can make it we can make a money class and have the operations on it. But then, of course, if it's an actual object, we can then change its value, right? So $5 can somehow be transformed into $10, which we would like, but the banks won't like, right? And so the value object, it's a very simple pattern to say, look, for these value things, yeah, we can make them a class, right? And make the object immutable. So when you create a money object, you can't ever change it. It's $5, and you can't change it to $10. Nor can the bank change it to $3, right? They can subtract, right, $2 from it and get a different money object, right, that represents that, right? Very simple pattern, right? And it's useful in 2 ways. The first one is realizing, oh, there's these simple things we deal with, and you may not want to use, the base types of your language to represent them, right? And the second one is, yeah, you make them immutable so that they behave like values instead of objects. So the question is, how do you deal with pennies, right? Well, once you encapsulate it into a class, right? How you represent internally is up to you. So just to maintain, well, there's 2 ways people do it. One is to maintain the proper accuracy, is you don't represent as dollars, you in turn represent it as pennies, right? Another way is some languages have fixed floating point numbers where you can specify how many decimal points are available. But you also want to be careful of what happens to arithmetic when if you want, so it's a very simple pattern, right? And it's in Swift, right? They have classes and they have structs. But structs are, when we hear the word struct, we think of the C struct, right? Where it's just a data structure. In Swift, a struct is more than a data structure. It can have methods on it. And there are several differences. One is, yeah, it can have fields, it can have methods. The default is immutable, so you can't change it. And when you assign it, right, it's copied. When you pass it in as a function, it's copied. When you pass it back, it's copied. Like a value, right? That's what happens when, so you can't. And they also have the let, right, where when you declare a variable to be of type let, you can't, it becomes immutable, right? And that's common in newer languages where, okay, you can declare a variable to be immutable so you can't change them. It isn't quite the same thing as making the class itself immutable so you can never change it. So people are incorporating this idea in newer languages. Simple, right? The pattern is just, you know, make it a value object, right? So you can't change it. I mean, it's so simple, it seems embarrassing to give it the title pattern, right? And it's one of the patterns that Martin Fowler talks about in his analysis book. Now going to the other extreme. The model view controller. The difference here is all the patterns we talked about don't tell us how to architect an application or a program, right? They say, well, you know, we can use a wrapper around this, or we can use an interpreter pattern to do this, but how do we structure our program? They don't, there's none of the patterns we talk about do that, right? So the model view controller is a pattern that says, here's how you put together a GUI application, right? The major structure of the application. And presumably everyone or nearly everyone has heard about the model view controller because pretty much every GUI system uses it or a variant of it. Now it turns out that the model view controller paradigm or pattern was created in like the 70s and used in Smalltalk. And I actually used the original model view controller pattern in Smalltalk, and it was a pain in the butt. And you know, since then, the meaning of what the controller is in the pattern has changed. Initially, the controller was, it just handled the mouse and keyboard events, and then controlled where it went, right? So it was painful because let's say you had a menu and you wanted a keyboard shortcut, right? So you wanted that information displayed in the menu, right? So in your view, right, when you created your menu, you had to tell the menu, oh, here is the character I want for the shortcut. That's all it did, right? But then the controller is the one that actually got the keystrokes, right? And so the controller, you have to program the controller to say, oh, on this keystroke, right, that means special, but it didn't, the controller just told, you know, decided what to do about it. It didn't do anything. It didn't do it, right? So then you went to the model and you had to create a function in the model to handle that particular keystroke. And so it was basically 3 separate places you had to deal with to do this shortcut because you had to display it in the view and the controller had to know what to do with this. had to realize, oh, this is a special character, right? And where does it go? Well, it goes over there, but normal characters went over here. So it divided things up. Later on, what they did is they created a lot of standard controllers. So they make a standard controller for the menu, right? And it will then, you basically gave the menu a callback on this keystroke, call this function over here, right? That made more sense because then I'd have to do it in 3 places. You had to do it in the menu to tell what function to call, and then you use the function to do the right thing, and then you were done, right? And that made more sense than doing it here and here and here. It's like, I get tired of it every 3 times. Like, why am I doing it 3 times over and over again? But the whole point is, as soon as you got this GUI right, you got problems. You want the same data may display different ways, right? And so maybe you want to do the pie chart, the pie chart and a graph, but it's the same data, right? And so you can't hard code the data to one particular display. You may need multiple displays. You want things displayed and updated immediately, so when something changes, you update it. And the changes, right? If you ever built a GUI application for real, you know that there's usually a designer, and they're going to be like, oh no, that's the wrong color. Oh, move it over 2 pixels, up 2 pixels, make it right. And they constantly do that. And your manager comes in and says, no, I want this over here now, right? And so that the UI can change a lot. And so it's nice to have it separate from everything else so that every time one of those changes you have to make, you don't have to go and muck in this code and you say, okay, go over there and do it, right? And then you want to cross-platform, you don't have to change the core logic, right? And so it divides it into 3 pieces, right? The view is just a display, right? It's what you see. It's all the windows and the menus and the dialog boxes and the buttons and whatever, right? And the model is, it's the core logic of what the application does. And the controller is just, well, originally it was the user input, right? And that meant keystrokes and mouse events. And then the model basically becomes all the logic, and it has a list of observers, right? That, when it changes, it'll broadcast the change. And so the model view controller uses the observer pattern, right? The model becomes the subject, and the view and the controller might become, right, listeners. And the view is just a display, right? And again, originally what happened is each view had its own controller. So you had the whole window, okay, that has this controller, and then there's a button controller for this button, and then you drop on menu, the controller for that. Those controllers are really simple, right? It's just, what can a button do? Well, it can be pressed and unpressed. It can be enabled, disabled. Right, and so the original view of the controller was it just handled the keystrokes, right? And right, it was keystrokes, mouse clicks, mouse events, all those, any sort of input device the user could use, right? And this was before touch screens. And you have these three pieces, right, that work together. The model contains the data and the logic. The view displays it, and of course, a view can cause changes in the model because you can enter another piece of information and hit submit, right? And it changes the model. The model does whatever calculation it needs to be, and then the view may need to be redisplayed. Right. So what the pattern means has slowly changed. When you do iOS development, Android development, right, there's a model and a view and a controller, and the controllers don't handle keystrokes, right? What they're handling is communication between the model and the view. And when you first start developing, people usually don't have models, they just have controllers and data in the controllers, right? And so the controller ends up doing all the business logic and the logic of how things interact with the view, right? And so the view plus the controller really make up that interface part. A lot of places, like I say, combine those two. In Smalltalk, what they did is a lot of places they combine them. So, so for buttons, you have a callback function, right? There is a controller back there, but you never see it. Just say, here's my button. When it's pressed, here's a function you call on this object. And there's a bunch of them. And it's, first example of an architectural pattern, right? It's how to put this application together. Typo. There's a lot of variants. Here's some variants to find on iOS applications. There's more. In the Microsoft world, they have their own variants that they use. The model view model controller is interesting. So the controller is responsible. Also, on app development, you have this small screen, right? And so in iOS world, what's displayed in one screen's worth is called a scene, right? And so the coordinator deals with, when applications go from one scene to another scene, it's going to take care of that. That may mean creating a new instance of a model or transferring the status from one model to the next model. It deals with creating the view, right? Is that transition from one scene to another, whatever needs to be done. And then they interpose a view model between the controller and the model. Part of the goal is to make sure the view and the view controller are independent of the model, right? And yeah, so that each scene has a view controller, and the view controller has no state. You pull the state out of it to make it simpler, so it doesn't get too complicated, and it doesn't have to worry about going between one scene to another scene, which normally happens. And the view model basically has properties or data that need to be displayed in the view in that scene. And that's extracted from the model, but they do it through transformations, right? And the way they do it, those transformations, they use reactive, well, they don't have to use reactive programming. What they do, right, is basically, okay, here's my model. I need to display all this information. I'm going to, here's the transformations, transform, just get the name I need, get this I need. And then when you change the model, right, since it's using reactive programming, the properties in the view model update, and that'll update the view, right? And often the view model is just setting up all the dependencies of the reactive chains, right? Here, this to be, change, transforms, and then becomes this value. Now this view can listen to that particular thing, right? And then, so that's how things are. There are lots of different ways people have tweaked the model view controller pattern. And the web world uses the model view controller too, everywhere, right? But again, they've modified the pattern and add variants to it. So again, from Martin Fowler has identified a number of different patterns used in the model view controller in the web world. And we'll talk about this on Thursday.